Howdy and welcome to section 0.7 Congruent and Similar Figures. We are going to start off with our very first vocab word, which is congruent, which means figures that have the same shape and size. This little guy here is the symbol for congruency, which is an exclamation mark with a little squiggly line over it. Now, what sides are congruent in these two figures? Well, the sides that are congruent are noted by tick marks. These little guys are tick marks. When they have the same amount of tick marks on a side or an angle, that means they are congruent. So for example, we would have side MN, and we label that with a bar over top, is congruent with an equal sign and a little squiggly, is congruent to AC. So I go AC with a little bar over the top. Also, I would have side N and K is congruent to C, side C and B, because they have the same amount of tick marks, and same thing for AB and MK. Now, with angles, angles is the same thing except they're not tick marks. They're more half circles, semicircles, but they have to have the same amount. So I'm going to go with this one and this one. Now with angles, how do we notate angles? Is angle C is congruent to angle N. Now we're going to label the corresponding parts of the two congruent triangles on this figure, and then we're going to write a congruent statement for the two triangles. So the very first thing that we're going to do though is label all the sides. So I'm going to find my tick mark. So here's the first one, and I'm going to say side BC, side over top of it, is congruent to DC with the bar over top of it. Notice how I'm starting with the angle with two little arcs in it, and then I'm moving towards the center with three arcs. So next side, I'm going A to C. So side AC is congruent to side EC because they have two tick marks. So side EC. And then finally, side AB is congruent to side ED. Same thing with the angles. Angles aren't too bad. You just have to label one, except there is one exception in this diagram. So we're going with one arc. So we label that angle E is congruent to angle A. Angle B is congruent to angle D. Now, can I say angle C is congruent to angle C? No, I cannot, so we have to be careful here. I want C to be the vertex, so I'm going to label C as the middle letter. So here I have ACB, so angle A, starting point A, middle point C, ending point B is congruent to angle, and now notice how I started with one arc, so I'm going to go over to my other triangle. Notice how I'm starting with the one arc again. You could start with the one with two arcs, but you would have to make sure that the other angle you start with two arcs. So I'm just going to start with angle E, then I go to C, D. C, D. And now how we write the congruent statement for this triangle, I say that triangle A, B, C is congruent to triangle E, D, C. And notice in what places that I put the letters that angle A is congruent with angle C. Angle B is congruent with angle D. Notice how they correspond with each other in what place of the triangle. Next, you have to ask yourself, are these triangles congruent? Well, congruent means they have the same shape. So do they have the same shape? Yeah, they both look like right triangles to me. But do they have the same size? Here's 3, here's a 6. So they do not have the same size. So these triangles cannot be congruent. However, they are similar that they have the same shape, but they do not have the same size. The notation for similar now is just a little squiggly, no exclamation mark or no equal sign, which would mean congruent, but they do have a little squiggly, which means similar. So triangle ABC is similar to triangle XYZ. So corresponding angles are, when they are similar triangles, corresponding angles are going to be congruent. So angle A is congruent to angle X, angle B, which with one mark, with 1/2 arc, angle B is congruent to angle Y with 1/2 arc. Now, corresponding lengths are proportional. So AB over XY, so we put the same side of the big triangle or the small triangle over the same side of the big triangle over the small triangle equals BC over YZ. So let's check that out real quick. Going back to this example, let's see if we have proportional sides. So I'm going to start with this side, and I'm going to go 6 equals, and this side is what side over here? 3, so I'm going to go equals 3, and I'm going to put 6 over this side, which is 8, and now I have to go back over here. What is on the same side on that different triangle? It's 4. Now there's a couple ways that we can do this. The first way I'm going to show you is just to simplify the bigger ratio or the bigger proportion. How do we do that? I just divide out by 2 on top and on bottom. Simplify your fraction, so we come up with 3/4. So 6/8 is the same thing as 3/4. So that would prove that it is a similar triangles, or those two guys are similar. Another way that we can do this, I'm going to use a different proportion. So I'm going to say 10 over, and then equal sign, same side equals 5. Notice how I'm putting 10 on one side of the equal sign and 5 on the other side of the equal sign. And now I'm going to use the bottom part, 8, and this bottom part, 4. Now we can also cross multiply. So 8 times 5 is 40 equals 4 times 10 is 40. So since 40 equals 40, I know that these triangles are similar. Now we have triangle PQR is similar to triangle WXY. We are asked to find the value of Z. So I already know that they are similar. So then I know that the side should be proportional. So I have to find the value of C. Well, the very first thing I have to do, I have to see what sides correspond with what. So I'm going to turn my triangle upside down, and I know my letters and my numbers are upside down, but it just gives us a better feel for it. So very first thing that we want to do is to make a proportion. So our proportion goes, I'm going to use the long side, 20, over, and then equals, what is that side over here? It's 5 over, and I'm also going to use this side because that's my letter. So I'm going to put 20 over 12 equals 5 over Z. And now, just like how you solved that last proportion, I'm going to cross multiply. So it's 20, and I'm going to try to make that look like a Z, equals 12 times 5 is 60. Now just solve our equation. So divide by 20, divide by 20. So Z equals 3. And the very last one is a word problem. So Jan's sunflower plant is 8 feet tall and casts a shadow 3 feet. So I have a nice little picture here that it has Jan's sunflower plant is 8 feet tall and it casts a 3-foot shadow. I know it's not drawn to scale. At the same time, Jan's house, which is at the same angle of the sun, casts a shadow 11.25 feet. Can we figure out the height of Jan's house? Well, notice what we have. We have, if you haven't seen it already, we have some similar figures, if I can draw it any better than that. So if we have some similar figures, why not use a proportion to see if we can find the height of Jan's house that I'm going to label x. So 8 on my proportion, I'm going to start with 8 over equal sign. Well, what on Jan's house corresponds with 8? That's x. Then I'm going to use 3 for the bottom of 8. Well, what corresponds with the 3 is the 11.25. Here we can cross multiply again. So we have 3 times x equals 8 times 11.25, which is 90. So we divide by 3, x equals 30. Bam! And he did it. Please remember that you have to show your units. What are units? We are talking 30 feet. Thanks for tuning in. Have a great rest of your day.